Copper amine synthesis and spectrophotometer lab.
Scanning across all wavelengths allows us to determine the best wavelength to use for our experiment. It also allows us to determine the lambda max. The lambda max is the wavelength where the most absorption occurs.
The wavelength that achieves the maximum absorption will be the highest of all the values. This is an example of it with a few different chemical compounds.
The Beer-Lambert law states that there's a linear relationship between the concentration and the absorbance, which allows us to use the absorbance value of a solution to determine the concentration.
Beer-Lambert's law's equation is the amount of light absorbed is equal to the molar extinction coefficient, the distance of the light covered, and the concentration of the absorbing species. This law combines Beer's and Lambert's laws. Absorbance is directly proportional to the concentration of the solution, so the concentration can be determined. An absorbance of 0 means no light was absorbed at that wavelength. In this lab, we were tasked with creating a stock solution, which was copper amine. We had to weigh out the copper sulfate pentahydrate and dissolve it in the water. After that, we had to add ammonia. After adding the ammonia, we poured it into the flask. Then, we took the flask and added more water to make it equal to the meniscus line. Then we had to mix it thoroughly. After mixing, we poured it into the beaker. We had made our stock solution. Then we weighed it. We got 137.095 grams. Then, we took some of the stock solution out and put it in the flask. We took out 5 milliliters of stock solution. We did this to make our first dilution. In order to make that dilution, though, we had to add water. We added about 20 milliliters of water to the meniscus line. After that, we poured it into the beaker and we had made our first dilution. To make the second dilution, we added 5 milliliters of the first dilution to the flask, and then we had to add about 20 milliliters of water, and we had made our second dilution. To make the third dilution, we took 5 milliliters of the second, added to the flask, and then 20 milliliters of water to make the third dilution. Then we headed over to the spectrophotometer. After zeroing the spectrophotometer with the water, we decided to take the stock solution's absorbance value first. We cleaned both sides of the cuvette and then placed it in the spectrophotometer. Next, we took the absorbance value of dilution 1. We did the same as before, cleaning both sides of the cuvette with the paper and got the absorbance value. Then, just as the same as the first two, we decided to take the absorbance value of dilution 2.
Alright, you're good. You just have to close it. Let's not dirty up again.
We pressed read and got our absorbance value. Repeating the same process as the first 3, we got our absorbance value of dilution 3. At the end, we decided to get the absorbance value of the ammonia with water. Here are our total values starting with 0, then the stock, dilutions 1 through 3, and ammonia with water. We found our absorbance values to be ranging in descending order with every dilution. Here's the chart we made with our values. After completing the spectrophotometer portion of the lab, we calculated the graph as shown before in all of our concentrations. We found the concentration of the stock to be 0.02 molarity. The following dilutions were 0.004 molarity for 1, 0.008 molarity for 2, and 0.0016 molarity for 3. After completing our calculations, our lab was done.